Hello. In this video, I will walk you through our labeling tool. This tool can be used to label 6D object poses in multi-view RGB images. The buttons on the top left can be used to reload the dataset from disk and to save it along with all labels. Saving can also be done by pressing the S button. Different keyboard shortcuts are available. They are shown in the user interface. Try to use them as much as possible as they can significantly speed up your workflow. Different scenes can be selected using the control on the left-hand side. All parts labeled in a specific scene are listed below. Each part can be selected, duplicated, or deleted. The button on the bottom can be used to add a new part annotation. Images of the selected scene from different viewpoints can be shown. Annotated parts are projected onto each image. The cat model corresponding to the selected part can be changed. The 6D pose of the selected part can be changed in different ways. First, the controls shown on the image overlay can be used to move the part along its local coordinate system. The part's translation and orientation can be controlled separately. Next, the pose can be changed by clicking the buttons on the left. The size of the offset that is applied can be changed. This allows both coarse and extremely fine control over the part's pose. The pose can also be edited directly using the controls in the bottom left. The opacity of the other parts and the selected part can be altered to improve the clarity of the visualization. The Override Colors checkbox can be activated to better distinguish different parts of the same type. Aligning new parts is not easy. In addition to manually tuning object poses, you can also label objects by identifying correspondences between image pixels and points on the object cat model. Let's see how this works. We'll delete this part label and add it from scratch. We add a new part label and switch to the Correspondences tab. Here, correspondences can be added by clicking the plus button on the right or pressing the C key. For each correspondence, we select a point on the object model and a pixel in the image. Enable Snap to snap to vertices of the object model. After setting at least 4 correspondences, press Enter to calculate the object pose. The object is now positioned at the newly calculated pose. Often this leads to a good initial position that can be refined by manual tuning from different viewpoints. For objects that are placed on a shared ground plane, it's often useful to duplicate an existing part label and move it along the ground plane. Let's see how this works in a different scene. Moving along a plane is possible by dragging the plane indicator in the translation control. The pose of this part can then be refined by rotating it along its own Z direction and fine-tuning its translation. Thanks for listening. Feel free to leave any comments or feedback on the project's GitHub page.